Hey all, how's it going? So, in this video, what I wanted to start doing was following up on how we worked with Rough as the code formatter in the last video. I wanted to look at another new tool that Astral here has put out called the UV, which it's I think a couple years old since I first heard of it, and it's what all the cool kids are using apparently. So it can just install dependencies a lot faster. It's meant to replace a lot of virtual environments. You can switch between them very easily. You can manage multiple Python versions. It's very disk space efficient because it's all written and compiled in Rust. So I wanted to kind of switch over to we've been using pipenv for package management, and that's been working well, but I want to switch over to this. So let's get into it. All right, let's see. So the first thing that I did here, I think this is already installed on my system, but I did pip install uv. It might say like it's already installed. Just as an aside too, like there are other ways to install it. You see you have curl commands that wget for Mac and Linux, and then on Windows you even have like a PowerShell command that you can use. If you scroll down here, it says there is like a PyPy version that you can get, which is what I ended up using, but just to be aware, like are these other ways that you can get it. So there's actually already a package created that will do this for us. So it's called migrate-to-uv. It has 918 stars on GitHub, forks, and it looks like recent commit. So it looks pretty up to date. So we can kind of use this. So we have UV installed globally now. So we can just use a command called the UVX, which is basically just UV, but being able to run it from the command line. And you can see under supported package managers, it does look for pipenv already. So what it will do is when you run it, it'll automatically recognize like what you have set up, and it'll attempt to create the pyproject.toml and uv.lock file from that so that you can just switch to using UV. Okay, so now we are on our project. We're in the root directory. So let's just do uvx migrate dash to dash uv. Okay, and you can see let's actually do a quick get status. Okay, so you can see that it deleted the pip file and it put in pyproject.toml and uv.lock. So let's take a quick look at that. So your pyproject.toml, that basically just has all of the dependencies that you have in it. I know that we switched to kind of a Docker approach. I'll get to that in a sec. And I put in the uv.lock file, which this basically has just a lot more of the like verbose information about like where you're going to get everything, so that other developers can use UV as well. By the way, I just refilled my coffee with my new Battlestar Galactica Yeti mug that I got from Amazon, so say we all. One feature that I really missed from pipenv, and honestly this is what kept me on this for the past couple of years, even knowing that like UV was so fast, was just having this scripts command. So being able to just run like pipenv run backend, and it just automatically runs a backend and stuff like that. So I put in a little bit of just research into like what other things could work for that. And we can use something called a Makefile. So let's do that now. So Makefiles are something they're baked into Linux distributions and the Mac operating system. And since we're using WSL on Windows, then it's automatically baked into that too. If you're using Windows, if you're using like PowerShell, you can use a package manager called Chocolatey to install the Makefiles. But anyway, once you have that up and running, uh, what you do to make a make a Makefile is you just call it Makefile with, and this is important, in uppercase M at the beginning. You can see that VS Code automatically recognize it. Yeah, sure. Let's install it. You can see it says C++ because Makefiles are something that are also language agnostic as well. So it's not specific to Python. It's used for a lot of development, but it can kind of serve a purpose. So I have a lot of code on my clipboard right now. So what this is going to do is this is going to kind of replicate the commands that we had in the pipenv file. So you can see we have front end, back end, test, full test, install. This is kind of a convenience command because if you remember for pipenv project, what other developers would do is they would run pipenv install to install all the packages. And UV, it's just going to be UV sync like that. And we have a linter, which we didn't have before, but I thought was kind of useful. You can see up at the top of this file too, we have something called .phony. So, so Makefiles are typically used with an actual file target. So it's going to actually look for like a file called front end and back end and stuff like that by default. So by declaring it as phony, which I guess it makes sense if you think about it, you're basically saying that, hey, these aren't files, these are just like commands that we want to run. It's just kind of like good practice to have, I guess. So let's try out make test. And oh, we didn't save this file. All right, but you can see like make was already, it was our recognized in our system. So make test. Oh, okay. So what you do on this is this is important too. Is Makefiles they use tabs by default, and they're very strict about that, just like Python files, I guess. So if you're not using tabs, then it will cause this error here that you're seeing saying missing separator. So what we can do, I actually didn't know this, but VS Code makes this very simple. You can just at the bottom here, where it says select indentation, and this is just a native VS Code feature. You can just press convert indentation to tabs, and then you might not be able to see that. Let me move my face. You can see Makefile. It does have a change, so it is it has the little dot there, so we can just save that now, and then just redo this thing. Say make test, and then we have errors failing just because we haven't really resolved them yet. But the point is that it is, I guess, doing things now. So that's pretty cool. Another really cool feature of UV that I mentioned at the beginning is you can actually specify the Python version directly in that, and it'll just like go out and download it. So if we did like dash Python, then do we need an equals? No, we just do like 3.10 or something like that. So UV lets us do that, which is really cool. What we can do is we can kind of use that to take advantage of kind of our Makefile setup that we have here too. So I have some other stuff on my clipboard. So up here we're specifying like an actual Python variable up here. So this question mark equals is basically saying that if we don't specify anything, then we'll just use 3.10 by default. And you can see a lot of these commands now you have UV run, and then you have, so if the Python variable is specified, then it'll use whatever you have in there. That's what's defined like in these parentheses here. Otherwise, it'll just do UV run streamlet run main.py like normal. So we can use that now. So let's see, let's actually, because I clipped this too, let's also do convert spaces to tabs, and yes, that is needed again apparently, because I pasted it in from somewhere else. So if we specify like make test, and then, so let's see, what we used before, we had Python 3.11. So if we say Python equals 3.10, then you can see that what it does here is it specifies Python 3.10 up there. We already have 3.10 on our system, but let me just show you if I use a version that we don't have, so 3.12, then it's going to download everything, and this is where UV comes in. It's super fast. Gets installed before I even finish talking. It uses Python 3.12. Just a quick note here too that the Python versions are specified by what we define in the uv.lock file. So we're saying that everything over 3.10 is what we will be supporting. So if we say like Python 3.8 for example, then it's going to download 3.8, but then it's going to look at uv.lock and say that, oh, this isn't in the required version, so we don't need to do it, and it's just going to throw an error and quit. Alright, so the last thing that I want to go over here before I wrap up is this pyproject.toml. I just wanted to talk about this a little bit. So, what this is this is meant to be more like a human readable version of the dependencies. So these packages here, these are like exactly what you would run with pip. We can have dev dependencies, so we have rough right there. One thing you'll notice is we have a warning saying the tilde is, it introduces some ambiguity, because normally if you have a tilde, you want to do a minor version to that as well. So you can see here the warning goes away now, because we're specifying the minor version. But what we actually want to do is we want to say anything over Python 3.10. We don't really care about a minor version right now. We have a name field here, so we can just name this CrossFit Streamlit. Yeah, with the lowercase s, that works. What we can also do is, because this is all put out by the company Astral, right? So in the last video, we made a rough.toml file just saying like some stuff that we want for like actual formatting and linting. So if we go ahead and let's pin that over to one side of VS Code and look at pyproject.toml, I have some stuff on my clipboard. Okay, so this is basically, we can take all this that we have in rough.toml and we can convert this over to the pyproject.toml. And you'll see there are a few things that are different. Like we have to specify exactly that we're talking about the rough tool, because pyproject.toml is meant to be a little more generic. Then instead of just saying format, we want to say tool.rough.format. And same thing for the linter as well. So what we can do now that we've done that is we can actually go ahead and delete this file. And then if we run, we can use our Makefile now. So we can say make lint. Oh, alright. So it looks like we can only have dashes in here, not spaces. So do that. Run the linter. Okay, cool. These are, if you remember from the last video, all the stuff about doc strings that I wanted to basically have for my linting rule. So, alright, so we have that. So I think that about wraps it up. In the next video, what I want to do is we can take a look more at the Docker-based layout. What we can do is we can actually run UV inside of the Docker container, and that's going to have the advantage of just being a lot faster than just using pip natively by itself. So thanks for watching, and I'll see you in the next one.